Hi everyone. Today we're going to be talking about radical expressions, and our only objective today is to learn how to simplify radical expressions. So first things first, let's define what a radical expression is. A radical expression is an expression that contains square root signs. Square root signs. Sometimes we call these radical signs. You'll encounter either one, both are fine. Examples of these include square roots of numbers, like the square root of 14, that's a radical expression, or square root of xy, or the square root of t plus s, or we can even have square roots that are fractions, like square root of x over 5, something like that. We'll see all of these. Let's define one more thing. This last definition is the radicand. So when we refer to the radicand, we're really talking about the expression under the square root sign. So the expression under the radical sign. So if I had something like this, square root of x plus y, my radicand would be x plus y. All right, so when we simplify radical expressions, our goal is to get them in their simplest form. And simplest form has three criteria. The first is that the radicand has no perfect square factors other than 1. So this is perfect square factors. And what this means is that we don't want to have something that's a perfect square under that square root sign. Our second criterion is that our radicand has no fractions. So we don't want any fractions in that square root sign. And the third criterion is that there are no square roots in any denominator. So we don't want any square root signs in any denominator. So it's a little bit tricky to think about this without context, so let's do some problems together. All right, so here's our only objective for the day. We want to simplify radical expressions. How are we going to do this? Well, we're going to modify our expression so that it's in simplest form. All right, so let's take a look at this first one. We have the square root of 2 over 72. We don't want fractions here, so that's one of our problems. Another one is that this fraction can be reduced. So let's do that first. We can get the square root of this fraction reduced, which is 1 over 36. I really just divided both the top and the bottom by 2. 1 over 36, those both look like perfect squares to me. So the square root of 1 is 1, and the square root of 36 is 6. So the square root of 1 over 36 is 1 over 6. That's simplest form. All right, number 2. Number 2 says the square root of 3 squared plus 4 squared. So we could simplify that inner part first. Let's see what we get. Square root of 3 squared, let's see. 3 squared is 9, so that's 9, and 4 squared is 16, so 9 plus 16. Square root of 9 plus 16, we can add those together. That's the square root of 25. Square root of 25 is 5. So this equals 5. Number 3. Number 3 is an interesting one. So we have the square root of x squared plus 8x plus 16. Now the thing about square roots, you can have anything under them as long as it's positive. So this guy right here, we know how to factor. Let's factor it first. So this is a perfect square trinomial, so we can factor it like x plus 4 squared. And since we have the square root of something squared, we can take that out, but we have to be careful here because x plus 4, what I'm left with, needs to be positive. I can never take the square root of a negative number. So I put absolute value signs around it. And that's our answer, the absolute value of x plus 4. All right, let's learn something new. All right, so when dealing with square roots, there's something we should know, and it's called the product property. So this property tells us that if we have the square root of some number times another number, or like a times b, we can separate these and make them their own square roots. So the square root of a times b equals the square root of a times the square root of b. We can only separate these if they're multiplied. We can never do this if these two are added together. So let's see this in action. If we have the square root of 18, we know 18 is 9 times 2. So this equals the square root of 9 times 2. Because these are multiplied, I can separate them. So I'll get the square root of 9 times the square root of 2. Now we know the square root of 9 is 3, so that'll be 3. And we can't do anything with the square root of 2. It's already in its simplest form. So this equals 3 square root of 2. Let's try another. All right, in number 5, we have the square root of x to the 4th times y to the 3rd. For the purposes of this problem, let's assume that all of these variables represent positive numbers, so we don't need any absolute values in the end. All right, so because these two are multiplied, we can separate them. So we'll get the square root of x to the 4th times the square root of y to the 3rd. Now you have a couple of options. We can separate these further, since the square root of x to the 4th really equals x squared times x squared, or you can recognize that the square root of x to the 4th is just x squared. But when in doubt, write it out. So we're going to write it out together. Also, square root of y to the 3rd is the same thing as the square root of y squared times y. That equals y to the 3rd. So let's separate these out. We'll have the square root of x squared times the square root of x squared. I'm using the product property on this guy down here, times the square root of y squared times the square root of y. All right, so now we can do some things with these. I'm going to erase this down here, and we're going to get square root of x squared, that's just going to be x, times another x, times a y, times the square root of y, which we can't do anything with. So now to take this a little bit further, this equals x squared y times the square root of y. And that's in simplest form. All right, let's learn one more property. Okay, the quotient property tells us that the square root of a over b, or the square root of a number over another number, can be separated out into the square root of a over the square root of b. So we kind of separate those like we did with the product property. So let's try one. Number 6 tells us the square root of 5 over 9. So we can separate this into the square root of 5 over the square root of 9. And we know the square root of 9 is 3, so this guy equals the square root of 5 over 3. This is in simplest form. Remember, it's okay if we have radical signs in the numerator, but not the denominator. All right, let's do another. Okay, in number 7, we have the square root of a to the 5th over 81a. Before we separate these, I want us to notice that this fraction can be reduced. So let's rewrite this. We can cancel one of our a's here in the top and the bottom. So we'll have the square root of a to the 4th over 81. Now we can separate these two. So we'll have the square root of a to the 4th over the square root of 81. We know the square root of 81 is 9. So we can put that in our denominator. Square root of a to the 4th equals a squared times a squared. So if I have the square root of a squared, square root of a squared times the square root of a squared, that gives me a times a, which is a squared. So the square root of a to the 4th is a squared, and my simplest form is a squared over 9. All right, now we can do some problems with the product and the quotient rule together. So let's do a couple and then we'll be done. All right, so in number 8, we have the square root of 80 over 25. Now we can use the quotient property right away. So we can split this up into the square root of 80 over the square root of 25. And the square root of 25 is 5. So we can make that our denominator. Square root of 80 is going to be something that we can break up. So let's think of 80 as 16 times 5. I know that might take a little bit of working with, but if you make a factor tree, you'll find out that you will get those factors. So we'll have 16 times 5, and because we have two numbers multiplied together, we can break those up using the product property. So this equals the square root of 16 times the square root of 5 over 5. And the square root of 16 is 4. So our final answer is going to be 4 square root of 5, which we can't break up anymore, over 5. All right, one more. Number 9 tells us the square root of 4x to the 5th over 9. So we can split this up using the quotient rule. So we'll have the square root of 4x to the 5th over the square root of 9. And the square root of 9 is 3, so we'll have 3 on the bottom. And the square root of 4 times x to the 5th can be broken up using the product property. So we can get the square root of 4 times the square root of x to the 5th. Square root of 4 is 2, so we'll have 2 up here and 3 in our denominator. Now what about this x to the 5th? X to the 5th we can think of as x to the 4th times x. So with that in our radicand, we can break it up using the product property again. So we'll get the square root of x to the 4th times the square root of x. And the square root of x to the 4th is x squared. So we'll get 2x squared times the square root of x over 3. And that's our final answer. All right, so I think you're all set to try those problems at the bottom of your guided notes. Thanks for watching.